Recording is on.
Started second recording. That's fine. So we are trying. Let me iterate. So now what we did is, right, we are setting hash path is small boolean variable to false. Now we are having all the boundary conditions, right? If row and column within the boundary, and if you find the character in the input string equal to the character that we are at the location in the matrix, right? And that character and that particular location is not visited. These are the three conditions, right? These three conditions are
Yes.
very important. If all these three are true, then we are going to the next level. Okay, path plus plus. Now we need to find this next element in the path, right? FCK. If you look at the FCK example, F we already found. Now we need to go for C. C is at the first location, right? So now we are incrementing to one path. At the same time, we are marking that value in the table to true, in the visited boolean table to true. Now here is the thing, right? We are going in all four directions from this point onwards. In this is the matrix. Go top means left minus row minus one column. Going left means same row, column minus one, that means it will go left, right? And go down means row plus one, column same column. Going right means same row but column plus one. But you can ask, oh, this could go to the boundary, this can go, any of these conditions can go out of boundaries, right?
Mm.
We are not checking here because that will be checked when the control comes here and it comes here. We are checking here on the line number 92. We are taking care of that boundary. We no need to check whether you are going outside the matrix or not. We are simply saying, hey, please find the next character, because we incremented path plus plus, path length plus plus. Please find the next character in the input string. Here is the visited character. We already marked one location as true, right? And here are the number of rows, here are number of columns. Please find here, please start from here. This is the starting point. We just incremented or decremented, right? It's the top left, go down. So we are going in all four directions. So we are
Mm.
trying top, and or we are trying left, or look at this R condition. If you find any of the locations, if you find the path in any location, we don't know, right? It could be top. If you go top, you can find the location. If you go down, you found the path. If you go up, you may find the path. if you has
Mm.
a if the has path becomes true, that means you have the path found, right? So if it is
Mm.
false, basically if it is false means there is no point. You went all four directions, but you did not find the next character. That's what it means, right? If it is false, what does it mean?
Yes.
If the line number 105, if the hash path is false, we did not find next character in any direction. So we don't take
Yes.
even this character. So now we are assuming, hey, this is better to take it. But after exploring all four directions, we got the false. That means it is no value of taking this character. It's just like the first F in the matrix I showed you. We are thinking we can find FCS with that F, but no, that's not good to take that F, right? Our assumption is false, correct? That's why whenever we have that problem, we are simply going back. No, we did not find F, like minus minus. It's kind of it's kind of going back. No, we need to find F again, right?
Yes.
So initially we thought, hey, we find F, let's find the C. But now that is not true. Like taking the first F is not good. So that's why we are reverting back. Okay, please take back and path minus minus. Now we also setting that location to false. Initially we set this location to true. We are assuming we found one good character, but that's not a good character to take,
Mm.
right? Now we are resetting to the path length, and we are reverting the path length. We are also resetting the value to false. Now simply it will go to the top here, and it will go to the next element in the matrix.
But how you are saying to not check again this F only? There means
We
understand.
can check. There is no, because let's say the input string has FC, FC, F or F something. that f could be used again. We don't know
Yeah.
that f, the f which we marked as false can be used for another character in the string. The input
Mm.
string is only FCS. If I say FCSEA something, like there could be another F that can be utilized for this F. So that's
Mm.
why we are setting that to false. So
Yeah.
starting that position is not good, but it could be used in the down the line. It could be used. We don't know this input string, right? Input string could be 10 characters or 20 characters. One of the characters may match with that if you're going in all the directions. That's why we are marking that to false for the time being, and we are simply going next. Let's say this becomes true. Let's say this becomes true. We are simply returns that true. Now what happens is, it's in the recursive way. One of these things becomes true, then that hash path becomes true. So it's a true, true, true all the way to true. Like if you find all the three characters, right? FC, yes,
Mm.
it becomes true. That recursive function again becomes true. It will again becomes true. Finally, FC, yes, you found true for the other input, right? So here is the fun. FCS. F we are assuming true, and if you're going C, it is true, and again going S is true. So finally, you found this like three characters, right? So input length is 3, and path length is also 3, because you are keep on incrementing, right?
Mm.
So in the situation going right, going right, going right, this is the recursive function that will give true all the times. You're starting with F, from F you go to right, again that will return true. From C again you go to right, that will return true. From C you can go to top or other directions, but all those three will give you false. From C, if you go top you did not find yes, if you go down you did not find yes, right? You cannot
Mm.
go left anyway, because left, if you go left anyway, you can, of course we can go to left, we are calling left here. But what happens is, here the visited is becomes true, right? Because you already visited this F.
Mm.
So you are calling all four directions. From C, you are calling all four directions. But what happens is, the top becomes false because top is C. Top is C. We did not find yes. And left also becomes false because this is already visited, right? Now E, down is also becomes false because we are looking for yes. FCS, let's say you are looking for yes, so it is not yes. Now for the right, you got the true, because you are looking for yes and you got the yes, and finally it becomes true, isn't it?
Mm. Yeah.
That's the thing. So
Suresh, like
yeah, so
in the first row,
yeah,
we in the first row we check right, left, top, and bottom. Right, while checking top, there will be chance of array.
out of bounds, you mean
Yeah.
out of bounds? Yeah, here is the condition, right?
Mm.
If it is out of condition, out of bounds, it will simply return hash path. What is the hash path? False. Simply. That's why we are
I
we
mean,
are having a variable
see,
here.
if we are in row one, A,
Mm-hmm.
B,
Mm-hmm.
we try all four directions.
Mm.
The first row we should not check for the top, right? We don't have a top row
Yeah.
as it is first row.
Yeah.
Where you wrote that condition, like how it's
So
working.
from let's say from A, you are calling all four times, all four directions. Go top, go
Mm.
left. So row becomes row already zero, right? Row becomes -1 because row 0 -1 -1. Okay, column becomes
Minus.
column is same column 0, right? Now you are
Mm.
going top of A. That means this hash path will be called with the row value. What is row value? -1, right?
Mm.
Now how many rows you have? Like row value is 2 rows, but now row value is greater than or equal to 0. Is it greater than 0? -1 is greater than or equal to 0?
No.
No,
Yeah.
so it simply returns
Yeah.
false.
Yeah. Got it.
So we are blindly calling. Even you are at A, I don't care. You are calling top of A, left of A, right of A, down of
Mm.
A.
Mm.
We are not checking while calling. While calling the recursive function, we are not checking. We are blindly calling all four directions. But this if condition will take care of that boundary conditions.
Mm.
We don't explore anything if the row is out of bounds, right?
Mm. Mm.
Yeah, even let's say E. From E, you just saying right, set right, right? What happens in this situation? If from E, if you are searching right, column becomes plus one. Column becomes like zero, one, two, three, four. Column becomes four. But how many columns we have? Columns become zero, one, two, three, 0, 1, 2, 3, 4. But how many columns? With the column length is only three.
Three.
Columns basically,
Index.
yeah. How many
Index.
columns we have? Indexes basically, right? So
Mm.
it becomes false. So it never enter into this loop because there is no element after E.
Yeah.
You don't need to explore anything right side of E. So this is boundary condition. Basically, these indexes are validated here. Okay, cool. Then yeah, it is tricky algorithm. It is not. I never asked this question in any of the interviews, but only thing I'm explaining because this is a basis for a lot of algorithms in the future, like depth first search and other algorithms. Okay.
Have you faced any this type of question in your career in
Mm,
interviews?
interviews I did not, but I think we covered similar problems, right? Like in the arrays we covered like setting all the
Yes.
columns to zero, setting whenever you find zero, you set all the columns to zeros, right? That is also
Yes.
similar
Yes.
thing. You take GRO, I think zero. Yeah, set matrix size matrix to zeros. Did you remember this algorithm? We used the same approach, right? We whenever
Mm,
you
yes.
find zeros,
Taking
we set
array.
all the row and column zeros. That for that algorithm also, I think we took another array, true false, right?
Mm,
So I think I
yes.
got that algorithm, not this algorithm. Yeah, this is not. I don't think this is a usual algorithm that you get in the interview, but even if you get this algorithm, you should be able to explain how your algorithm works, how what is the approach, and just whiteboarding is enough for this algorithm. If you try to write it down, there could be a way like it's not we cannot write 100%. At least you should be able to explain the what are the inputs of this algorithm, like what are the inputs that you're going to put for this and how this works. um, yeah, it depends. In some companies like Microsoft or Google, they might ask this. They want to see how far you can go, right? So yeah,
Mhm.
it's not like they expect to write. They expect you to write
Mm.
100% valid code, but you should be able to explain all this how this works. If you say this is DFS, you will get 30 points. If you say you will take another matrix for visited, you will get another 30 points. You are 60%, you already answered because you are at the right track, right? And the rest of the 40% of the thing is you have to impress the interviewer by having like this for loop, and also how you going to do this. Just explain like while you're writing the code, these boundary conditions and very important, like, and these conditions, this is very very important. I will give at least 20 points for this writing these conditions from like going all directions. You should be able to handle how to go left, how to go right, how to go top, how to go down. That managing the indexes, you are already in a good shape. If you're able to write these minus ones, plus ones, all these things, then I will give another 20 points for that candidate. Oh, he knows how to navigate, right?
Yeah.
That's how it is.
And Suresh, what can be time complexity?
Very good question. Time complexity. You can simply look at here. We are navigating all the elements. This is definitely order of. Um, not only that, we are visiting every node, and also you are going to the depth of every node, right?
Mm.
So it will be n by m. Even I need to figure that out. I don't know. So for every node, is it log of Log of n by m, I don't know, because for every node you're going to start exploring, right? So you start with
Yes.
every node, that means n by m. So you at the worst case, you scan all the elements, which is n by m, and also from each node you are going depth first search. So I need to find um, the complexity for depth first search. Okay.
Yeah.
Yeah, so that it's a multiply of that depth first search with n by m. So let's look at the graphs. I think if I go down depth first search, here is depth first search. Yeah, so I did not even note down here. So depth first search, we need to find the complexity for that. That will be multiplied with n by m. So every time you start with it and you go in all directions. Yeah. Cool. Yeah, it's a complex algorithm, but please walk through and go through that whenever you get some time this week, so that you will remember all these, for loops and the discussions what we had. Okay.
Yes.
Cool then. Okay, I'm going to stop share, stop recording.